from the Woodlands Waterway in the Woodlands, Texas. Toups Graphics presents a tutorial video over the growing number and starting number. The growing number and starting number will help you generate linear expressions from tables, verbal descriptions, and graphs. First, let us learn how to generate a linear expression from a table of values. Let's learn to generate an expression that would give you the values from the below table. Before we start, let's look at our table of values. The top numbers are the term numbers. They are usually 1, 2, 3, 4, and so on. The term number will turn into the x-coordinate of an ordered pair that you will later graph. And the term number will eventually be the domain of the function represented by the algebraic expression. Meanwhile, the value numbers are numbers that will be generated by using the term number in your algebraic expression. The value will also be the y-coordinate in an ordered pair of x, y. And the value will eventually be the range of the function represented by the algebraic expression. The first thing you need to do to convert the table to an expression is to make sure your term values do not skip. If they skip, you need to rewrite the table. You also need to remember that linear expressions will have common differences between the value numbers. The common difference can also be called the rate of change of the algebraic expression. The common difference, or the rate of change, will equal to the growing number, which will help us generate the algebraic expression from the table of values. Now you'll find the growing number. To find the growing number, find the common difference in the values. To do this, look between the value numbers of 811, 1114, 1417, and 1720. If you subtract 11 and 8, 14 and 11, 17 and 14, and so forth, you will always get 3. In this expression, 3 would be the common difference, the constant rate of change, or it would be called the growing number. Since we know 3 is the growing number, now it's time to find the starting number. The starting number is the value number paired to the term number of 0. Most table of values will not have the term number of 0 included in the table. To get the starting number, you need to add 0 to the left of the term number of 1 and use the pattern to find the value. In your table of values, go to the left of 1 and add a 0. On your test, you may have to write 0 over the term number. Now use the pattern and find the number that would go under the 0. A good trick is to get the 0 term, add the opposite of the growing number to the value of 1. In this problem, our growing number is 3, so the opposite would be -3. The next step is to add the opposite of the growing number to the value of the term number of 1, which is 8. 8 plus a -3 is 5. So 5 would be your starting number. Now we know that the growing number is 3 and the starting number is 5. We could use the formula Gx+S to generate our algebraic expression where x equals the term number. Now that we know that the growing number is 3 and the starting number is 5, let's replace G and S in Gx+S with the 3 and the 5. Our algebraic expression would be 3x plus 5. Now let's check our answer. If we replace x with 5, we should get a value of 20. 3 times 5 plus 5 is indeed 20. So 3x plus 5 is the algebraic expression that would generate our table of values. Today's video over the growing number and starting number is produced by the common difference. Do you need to find the growing number? You need to find the common difference. And the median. Do you need to find the middle number of a list of numbers? You need the median. We'll return back to the Woodlands after this commercial break. Do you need help on the STAR test? You need the Pentagon T cell phone app. It will show you how to convert fractions to decimals. It will show you the different types of angles. It will show you how to graph a point on a coordinate grid. It will show you how to prime factor a number. It will also show you the common fraction, decimal, percent conversions. The Pentagon T cell phone app. It will help you always believe. Now it's your turn. Find the algebraic expression that gives you the value numbers from the table. Remember to find the growing number and starting number and use Gx+S. First, you need to find the growing number, which is also the common difference. To get the common difference, find the difference between the value number. In this problem, if you subtract your term values, you always get 6. Now that we know that our growing number is 6, we need to find the starting number. Add 0 to the left of 1 in your term number position. Now that we've added a term number of 0, remember to get the starting number, add the opposite of the growing number to the term number of 1, which is 14. To get the starting number, we need to add 14 to the opposite of the growing number, or -6. 14 plus -6 is 8. So our starting number is 8. Now we'll substitute 6 and 8 into the equation Gx+S. If we replace G with 6 and S with 8, our expression would be 6x plus 8. Now let's see if it works. If we replace 5 with x, we should get 38. And indeed, 6 times 5 plus 8 is 38. So the expression 6x plus 8 generates the values. Let's change things up. See if you can find the algebraic expression that gives you the value numbers from the table below. Remember to find the growing number and starting number and use Gx+S. Remember, you must find the growing number first by finding the common difference. In this table, the value numbers get smaller. If the value numbers get smaller, then the growing number will be negative. In this problem, we need to get from 25 to 21 to 17 and so forth, so we'll add -4 to the value numbers. The growing number would be -4. Now that we know that the growing number is -4, let's find the starting number by adding the opposite of the growing number to the term value of 1, which is 25. We'll add 25 plus 4, which would be 29. Now that we know that the starting number is 29, let's replace G and S with -4 and 29. If we did that, we would get -4x plus 29. So -4x plus 29 is the algebraic expression that gives us the table of values. The growing number and starting number is sponsored by positive correlation. Do you have a positive growing number? Your table of values has a positive correlation. We'll be back to the Woodlands Waterway after this commercial break. Are you having trouble with a problem on the STAR test? You need the Pentagon T eraser. It works in reverse. The Pentagon T eraser. It will give you more power to do your best on the STAR test. Just apply the Pentagon T-Eraser on a griddable answer grid and watch the answer magically appear. The Pentagon T-Eraser. It will help you always believe.
But wait, there's more!
If you order now, you'll get the Pentagon T tote bag. It will help you accessorize any outfit so that you will always believe. The Pentagon T-Eraser and tote bag can be yours for the low price of 4/5 of $100. Call 1-888-PASS-STAR. That's 1-888-PASS-STAR. The Toups graphics tutorial video over the growing number and starting number continues. Find the algebraic expression that gives you the table of values. Remember to use the growing number and starting number. First, let's find the growing number by finding the common difference of the value terms. We need to find the difference between 11 and 3, 19 and 11, 27 and 19, and so forth. If you subtract those numbers, you would always get 8. So 8 would be the growing number or common difference. Now we need to find the starting number. To do that, find the value that corresponds to the term number of 0. The 0 term will be the starting number. To get the term number of 0, you need to add the opposite of the growing number to the term value of 1. So we'll add -8 to 3. 3 plus -8 is -5. So our starting number would be -5. Now we could replace the 8 and the -5 into the formula of Gx+S and get our algebraic expression. It would be 8x minus 5. 8x minus 5 would be the algebraic expression that would generate the value terms. Now see if you can find the algebraic expression that gives you this table. Remember to find the growing number and starting number and use Gx+S. Remember, to get the answer, you need to find the growing number first. The difference between the value terms would be 9. So our growing number would be 9. Now that we know that the growing number is 9, now we need to find the starting number. The starting number will equal to the value where the term number is 0. So we need to add the opposite of the growing number to the value of term number 1. If we add a -9 to a -3, we would get -12. So our starting number would be -12. Now we know that the growing number is 9 and the starting number would be -12. We could replace 9 and -12 into Gx+S, giving us 9x minus 12. So 9x minus 12 would be the algebraic expression that gives us the table of values. The Toups graphics tutorial video over the growing number and starting number is sponsored by Negative Correlation. Is your growing number a negative? Then your table of values has a negative correlation. And Scale Factor. Do you need to reduce or enlarge an object? You need to multiply the edges by a scale factor. And Origin. Do you need to graph a coordinate? You need to begin at the origin. We'll return to the Woodlands Waterway after this commercial break.
Aren't these Pythagorean triple meal deals great? I'm going to get the 3, 4, 5 meal deal. For $5, you get 4 tacos and 3 Frito chili cheese wraps. What a great deal!
That is a good deal, Dad. But I think I'm getting to get the 5, 12, 13 meal for $5. And you get a 12-inch hot dog and 13 tater tots.
Wow, what a cool deal.
I know.
You know what I'm going to think of it? I'm going to live life on the edge. I'm going to supersize my 3, 4, 5 meal deal with a scale factor of 2 and make it a 6, 8, 10 meal deal. For $10, I'm going to get 8 tacos and 6 frito chili cheese wraps.
That's a lot of food.
Don't worry about that. I'm a manly man type of guy. It's so cool supersizing your Pythagorean triple meal deal with a scale factor. You know, you take a girl down here, use a coupon with your order, and show her how to use the scale factor. Talk about being a babe magnet.
The Pythagorean triple meal deals, only at Sonic. From the Woodlands, Texas, at the fountains at Waterway Square. The Toups graphics tutorial video over the growing number and starting number continues. You've just learned that the formula Gx+S can be used to generate an algebraic expression from a table of values. The formula Gx+S can also be used to generate an algebraic expression from a verbal description. Let's take a look at this verbal description. Bubba Bob has $25. He earns $12 for each yard he mows. How much money would he have after mowing 8 yards? This problem involves a linear relationship and can be solved by using Gx+S. Let's first find the value of G, which is the growing number. If you read the problem, the amount of money he has is going to grow $12 for every yard he mowed. Now that we know the value of G is 12, let's find the value of S, which is the starting number. If you read through the problem, Bubba Bob begins the problem with $25. The 25 would be the starting number. Now that we know that G is equal to 12 and S is equal to 25, we can substitute the values into Gx+S. That would give us an algebraic expression of 12x plus 25. Since we need 8 yards would be the term number of 8. We'll replace the value of x with 8. If you do the arithmetic, 12 times 8 would be 96. So now we have 96 plus 25 to find how much 8 yards would be. 96 plus 25 would be 121. So after Bubba Bob mows 8 yards, he will have $121. Now it's your turn. See if you can solve this by using Gx+S. Emma Sue has $30. She earns $8 for every hour she babysits. How much money will she have after 15 hours of babysitting? To get the answer, let's first find the growing number. If you read the problem, her amount of money will grow $8 for every hour she babysits. So 8 would be the growing number. Now let's find the starting number. If you read the problem, Emma Sue begins the problem with $30. So $30 would be the starting number. Now that we know that the growing number is 8 and the starting number is 30, we could replace 8 and 30 into Gx+8. That would give us an expression of 8x plus 30. Since we want to know how much she makes after 15 hours, we'll replace x with 15. 8 times 15 plus 30 would be 120 plus 30, which would equal to $150. So after 15 hours of babysitting, Emma Sue would have $150. Now let's bump up the difficulty a little bit. See if you can solve this problem using Gx+S. Jimmy John owes Bubba Bob $25. He wants to go to the fair, but he needs $50. He can earn $15 each hour as a Sonic cook. How many hours does he need to work to get at least the $50? To begin, we need to find the growing number. If you read the problem, you can find out that he will grow his money by $15 each hour he works as a Sonic cook. So the growing number would be 15. Now that we know that the growing number is 15, we need to find the starting number. If you read the problem, Jimmy John owes Bubba Bob $25. So he doesn't start off with a positive 25, but the starting number would be negative 25. Now that we know that the growing number is 15 and the starting number is negative 25, we could replace the values of G and S with those quantities. That would give us the algebraic expression 15x minus 25. To get the answer, we'll need to set our expression 15x minus 25 equal to the $50. Now we need to find the value of x that would make our expression equal to the $50. To find the value of x, we need to first combine the constants of 25 and 50. We'll add the 25 to move it from the left side of the equation to the right side of the equation. If you combine the 50 and 25, you would get an equation of 15x equals 75. To solve this for x, we'll divide both sides by 15 and get an answer of 5. To check it, let's replace 5 into our original Gx+S equation. 15 times 5 minus 25 would indeed be 50. So it would take Jiminy John 5 hours to get the $50. This Toups Graphics video production of Growing Number and Starting Number is sponsored by Percent. Do you need to compare a number to 100? You need a percent. And by Area. Do you need to cover a surface with square units? You need area. And by Pentagon T. Do you need to believe? You need Pentagon T. We'll return after this commercial break. Do you need to simplify a ratio? You need to find the GCF. The GCF reduces any ratio. First, write out the factors of the numerator and denominator. Next, circle the largest factor occurring in both sets. Now that you know the GCF is 6, divide the numerator and denominator by the GCF. That gives you the simplified ratio of 2/5. The GCF, it gives you more power. We're back at the Woodlands Waterway. Let's do one more problem. Lucy Claire has $40. How many days can she purchase a $3 lunch with the $40? To get the answer, let's first find the growing number. She's going to purchase a $3 lunch, which would make her $40 decrease. So the growing number wouldn't be positive 3, but a negative 3. You can also see that she started off with $40. So the starting number would be 40. Now we'll replace negative 3 and 40 into Gx+S and get negative 3x plus 40. We want to find out when she'll run out of money, so we'll set the negative 3x plus 40 to equal 0. Now we must solve for x. First, we'll subtract 40 and get negative 3x equals negative 40. Now we need to divide by the coefficient of negative 3. If you divide two negatives, you get a positive, and 3 goes into 40 13 1/3 time. If we find the value of 13 days, that would be $39, while 14 days would be $42. So Lucy Claire can purchase lunch for 13 days. In summary, The formula Gx+S can help you generate an algebraic expression from a table of values or a verbal description. In the formula Gx+S, G is the growing number. The growing number is also the common difference or the constant rate of change. The variable S is equal to the starting number, and the starting number is the value of the zero term. This video has been produced by Toups Graphics.
Always believe.
Pentagon T, always believe.